I did. Did you eat dabat yesterday? Dabat yesterday? Yeah? You eat dabat yesterday?
I ask because I want to make sure that you understand me. Yes? Is fine? Yeah? Okay, good. Alright. I'll give you a lecture on physics. This lecture was first originally given by a Dutch professor, Robert Dijkgraaf, and he gave a lecture on the Big Bang, but not to a class, to the whole country, on national television. In the evening, the whole country was watching, and he gave an excellent lecture, so I thought I'd try to do the same for you, yeah? So, this lecture is on the Big Bang and the universe. Yeah, you know the Big Bang? Yeah? Start of time? The creation of the universe? Okay, the universe. First of all, a question. We're gonna do some orientation. Where are we? Where are we now? Where are we? In the classroom. We're in the classroom of which school? JMC? And JMC is the best school in Pokhara? And Pokhara is the best city in Nepal? And Nepal is the best country in the world? And our world is the center of the universe? No. Our world is not the center of the universe. 1,000 years ago, people thought Earth, center of the universe. You know, you had the Earth, and then you had the heaven and the stars, but everything was Earth. You know, it was the most important thing. It was the center of everything. Then there was one scientist, Copernicus. Copernicus was a famous scientist, and he said, "No, you're wrong. The sun is the center. We all go around the sun. Our world goes around the sun. It's more important, not the Earth." And then came Galileo. You heard of Galileo? He had a telescope. He had a telescope and he looked at the planets. He saw the solar system. Yeah? And then there was Newton. And he said, there's gravity, and gravity keeps the solar system together. You know, we're all revolving around the sun. And this is how it works. I don't know why, but this is how it works. Okay. Now we're gonna draw a solar system. Anyone wants to help me? Yeah? Who wants to draw? Yeah? Can you draw? Yeah, come on. You can draw? No? Okay, so Deep, you have to draw. Okay. Here, tell me. Okay, we're gonna ask. Wait. So, what's in the middle?
Sun.
Sun. Good. What's the next one? Mercury. Yeah? Venus. Earth. Mars. Asteroids. Where are we? With a J. After Mars. Jupiter. What's after Jupiter? Saturn. What's after Saturn? Venus. Good. And then? You know that better than I do. I had to put my Okay. Yeah? So, this is right? No? I think it's right. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Venus, Neptune. Now we have one question. Is this to scale? Is the sun this big? And the Earth that big? And this close? Are they this close together? No. The sun's that big? Okay. So now we're gonna for orientation, I'm gonna pretend that this is the sun. Yeah? Okay. Can you hold the sun? Hold it up. If that is the sun, how big do you think is the Earth in comparison to the sun? Like what? Yeah? This is peppercorn. Peppercorn. This is the Earth. How far do you think, if this is the size, how far away from the sun is the Earth? The Earth is actually about 10 meters away. If you compare this. So if you can hold the Earth, yeah? Good. Okay. The rest here, empty space. Okay, there's Mercurius, somewhere here, Venus, somewhere here. But the rest is all empty. There's nothing. Nothing there. What else? The moon would be a grain of salt. And it would be 3 centimeters away from the Earth. 3 centimeters. And then we have, do you know our largest planet? Jupiter. I think Jupiter is approximately this. Yes. So, if someone could take Jupiter, yeah? Where do you think you have to go? You have to go outside. You have to go to the other room, 50 meters away. The rest is all empty, 50 meters away. Do you know the nearest star? The nearest star to the sun? Alpha Centauri is the collective name. The one is Proxima Centauri. Yeah, you got it. How big do you think it is? If that's the sun. Proxima Centauri very small. And do you know where you have to go? You have to go to 2,000 kilometers, Bangkok. This is important. This is how big it is. The next star is in Bangkok. The rest is all nothing. It's empty, yeah? Yeah. The universe is empty. There's nothing there. Okay. I think that's good enough. And then 100 years ago, up to 100 years ago, we only knew about the solar system. There was other stars, we didn't know what they were. And then we realized there is galaxies. Now, what's the name of our galaxy? Milky Way. Yeah. I tried. I tried to draw a little picture of Milky Way. is a bit like Chi-Chi. Chi-Chi. It's like Spider, yeah? We think the Milky Way is, it's kind of round, like this, yeah? But actually most stars are in these spirals, in these arcs. And here, you can pass this around. This is Milky Way, we can pass it around to everyone to see. And the sun is, we are not the middle, we are not the center. We are not even the center of the Milky Way. Our sun is somewhere 2/3 away in the bottom. Yeah, so quite far away from the center. And our galaxy, we have a little neighborhood. Yeah, it's not just our galaxy. First I was going to say something else. Okay, the Milky Way. How long across? Do you know light years? You know light years? Okay, how many light years across? It's approximately 100,000 light years. No, it's very big. Yeah. How many stars? 100 billion stars. What's this? 100,000. 100 million. 100 million. 100 billion stars, like the sun. That's too many. Yeah. What is Can you imagine 1 billion? 1 billion is so much. You know, 1 billion seconds. You know how long 1 billion seconds is? 31 years. You have to wait 1 billion seconds. If you count all the stars, you'll be busy for 310 years just to count the stars. So that's that many. Oh, too many. What else? The sun is also this rotates. It's rotating, yeah? Slowly. So the sun makes a circle, goes around, and that is 1 year for the sun. That's one year. The sun is only 20 years old. The sun is rotated 20 times in his life. And he can go 30 more times before it's the end of the sun. And you know how long it takes? 200 billion Earth years to go around. So a very long time. So the sun has been going around. Yeah? We are now here. Last time we were here, there was dinosaurs walking on Earth. Last time the sun was here. The rotation. Yeah. So yeah, this is 100 years ago. Galaxy is everything. Yeah, was their universe. But then we found more galaxies. So nearest galaxy to our galaxy, to Milky Way, is Andromeda. Who said Andromeda? Yeah, very good. Very good. You know Andromeda? You know anything about it? Same size. It's approximately same size. And they are 2 million light years away. And they are moving towards each other. Yeah? And they're going to crash into each other. You know what's going to happen? Oh, man, that's very dangerous. It's not in the news yet. It will be in the news in 2 billion years. In 2 billion years you open newspaper. Oh, Andromeda about to crash into Milky Way. You know what's going to happen when they crash in? Nothing. I'll tell you. If that sun, next star is in Bangkok, empty space. Everywhere is empty space. You know, nothing crash. It's too much empty space. The two galaxies come together and become one. They become one, slowly. Maybe in the center, heavy objects, they don't crash. For the rest, no problem. Yeah. There's another one. There's one other galaxy near us. It's called Triangulum. And those three are our neighborhood. That's, you know, it's far away. It's 2 million light years away, but that's our little neighborhood. It's like Pokhara. Okay. But then there's more. There's more galaxies. We know now the whole universe. Yeah? Nowadays. How many galaxies are in the universe? How many Milky Ways? 1 million? 1 million is a lot, eh? 1 million galaxies. Could you imagine 1 million galaxies? So much. No, actually, it's a lot more. It's again 100 billion. 100 billion galaxies in our universe. Approximately, yeah? Not exactly. I didn't count. Yeah. And also, within the universe, the galaxies lie in strings. So they lie together, like our little neighborhood of 3. There's bigger neighborhoods, and there's kind of one center, and there is the capital galaxy, like Kathmandu of galaxies. And his name is M87, and he is 200 times the size of our galaxy, like a lot bigger, and a big black hole in the middle. Okay. Now we know where we are, yeah? In the universe? Good. Let's go to how old the universe is. How old is the universe? Does anyone know? Okay. The universe is 13.7 billion years old. Yeah? 13.7 billion. That's why here's my history. First billion years. The second billion years. Yeah? Here are my 14 parts of 1 billion year history. And I've written down my history in my books. Yeah? And so we've got 14 books. It's our whole history. And every book has 1,000 pages. Actually 800, but 1,000 pages. Yeah? And every page is 1 million year. Yeah? 1 million year of history on one page. That's how much history we have. So, where is the Earth? When did the Earth come to exist? The Earth started there. Yeah? 4 books. 4 books on the Earth. That's how old it is. The first 3 books, there was life really early. Really early. First 3 books, Earth, bacteria. Oh, boring. One just small bacteria, maybe slightly bigger bacteria, but only 3 books of bacteria. Then the last book, we find life. Life as we know it. In the last book, we look at the beginning, we read about some fish, amphibians, yeah? We go 3/4 into the book, we read dinosaurs, 200 pages of dinosaurs, yeah? A long history, they did it for a long time. When we come to humans, the predecessor, not the modern human, the predecessor of the human, 3 pages, last 3 pages of this whole history, human, yeah? When we go to the human, modern human, that used an axe, you know, that used stones, that's carved. It's just last paragraph. Last paragraph. Last paragraph. If we go to the history, last 2,000 years, you know, we read about the Romans or maybe Egyptians as well. Last word. Last word. Us, Pokhara. Just a dot. Dot at the end. In the whole of history. Okay, it's interesting. Earth is interesting. But what is more interesting? There is a first book. There is a start. Why? Why is there a first book? We thought maybe there wasn't a first book. You know, maybe the universe was forever. But there is a first book, and why? And how do we know? know because of one man. He is the most famous scientist you know. What is his name? 100 years ago. Einstein. Einstein, most famous scientist, you know Einstein? Yeah. I think so. Why is Einstein famous? If I say Einstein, what do you say? Huh? The Big Bang. Yeah? Most people will say E equals okay. But yeah, there's many things he was famous for. Most people know this. But there's one thing he did that no one else did. I walk through space, I look at my watch, time, space, two different things. Yeah? It's not the same. Einstein thought, maybe they're together. Maybe space and time, they are linked. If I change something in space, I change something in time. This was, this is something we use every day, space and time. I use my clock, I use my, I go from one place to another place, but the place is always the same in a new time. But he thought different. And when he used this to come up with theory and mathematical model, and he surprised even himself. Now, Newton explained gravity, yeah? Did he explain gravity? Or did Newton actually did one thing? He written down rules for gravity. He written down F equals ma and laws of gravity. But Newton said, this works. I don't know why. Why two bodies of mass attract each other? I don't know. And then Einstein said, actually, it's different. And I know why. I can explain why bodies go towards each other. It's a property of the space. And he said, space is curved. He said, if you walk straight, then if space is curved, you actually walk in a curve. So, what's time? Maybe we have time for a little experiment. So here, yeah, this is, can everybody see this? Did you stand in the back? Okay, this is something traveling into space, and this is my space, yeah? If I go that way, I go that way. You always go straight, yeah? Doesn't matter, if you go straight, you go in one line. Yeah? Okay, if I walk straight, I walk straight. Yeah, that's what he does. But now, okay, we go to the middle. So now I need some people. Okay, you hold this hand. You, can you hold this hand? Okay. You, can you hold this hand? Yeah, oh, some people. And really tight. So this is space, yeah? My ball traveling straight. Yeah, travel straight. But now I put heavy object, heavy mass, a star. I put a star in my space. So if now my ball is going roll straight, you roll straight. If you roll straight, you start circling. Your space is bent. So it's not the gravity. It's not a force that pulls it that way. It's actually the space around us that is round, curved. And that's why, yeah, thank you. That's why it goes back. So that's what Einstein realized, that when he thought about space and time again, and he worked out his theory, that a mass would bend space. That's what he realized. Yeah, and that's a very difficult study. You have to read the Einstein books to understand. But he said, this is what happens. But okay, but to us it's the same. Whether it's gravity that pulls, yeah, or whether it's curved space. Both theories seem right. Why would Einstein be right? And why would Newton be wrong? Yeah? And then he said, there's one thing that would not be attracted by gravity. Yeah? What's that? What has no mass? What has no weight? Light. Light is not attracted by gravity. It's not like, oh, I'm a light. I fell off the building, I'm light. No. But Einstein said, this is the test. If light is curved, then it's because space is curved. Yeah? Not because he's attracted, but because space is curved. So what did he say? He said, if we look at two stars at night, we can see them respective to the rest of the stars and to each other. And if we look at them near the sun, yeah, heavy mass of the sun, we should see something different. And he was like, that's the test. And then everyone was like, how are you going to look at a star next to the sun? I can't even look at the sun. They're blind, you know. So, how do you look? Can you look at stars near the sun? Is there an option?
Telescope.
Telescope?
Telescope. Telescope.
What's that? Oh, telescope.
For the stars, telescope.
Telescope, yeah.
The north object is near to the sun.
Yeah.
Telescope. The scientific telescope for the not damage our eye due to
Yeah.
the sunlight.
Okay. But now this was 100 years ago. This was 1919.
Not possible.
And they thought of something clever. In 1919, what happened? Near Africa, there was a solar eclipse. The moon went in front of the sun. So we could look. So, yeah, solar eclipse is what they used. In 1919, an English group by, who was led by Arthur Eddington. Yeah, Arthur Eddington went to the coast of Africa, to a small island, and went to look at the two stars that he looked at before. And what did he see? It was bent. Einstein was right. Yes, we're going to tell Einstein he's right. And so he got back to England. But what happened before 1919? World War I. Where was Einstein? In Berlin. England, Berlin? Wow, no good. They had war. They couldn't talk to each other. Yeah, so they found